Going on now to Chapter 2, learn Topic 1, the Cartesian coordinate system. Here are the objectives. We're not going to spend a lot of time. It's generally a good review going over a number of topics. Now, as we go through this, we're going to show you how to build a coordinate system. We'll go over the vocabulary as we see some here, the ordered pair, x, comma, y, in parentheses. And then now let's take a look at a typical graph of a coordinate system. Now it's made up of two number lines. This one's the x-axis. This is the y-axis. As you see, the x-axis is horizontal. The y-axis is vertical. And they meet at 0. So the ordered pair at their intersection is, in parentheses, 0, 0, which is referred to as the origin. Now, if you wanted to make a sketch of this, that would be useful. Now, when you have two lines crossing like this, they divide the plane into 4 regions, which are called quadrants. Here is the first quadrant, and they use Roman numeral numbers, the second quadrant, third quadrant, and fourth quadrant. You'll note that the x in the first quadrant is positive, and the y is positive. In the second quadrant, the x is negative, and the y is positive. In the third quadrant, both x and y are negative. And in the fourth quadrant, the x is positive and the y is negative. In example 1, we're going to ask you to do some very simple things of plotting these points, these ordered pairs, on a graph that you're going to sketch. So you make a horizontal axis and a vertical axis, and then sort of equidistant set up some values. On this side, these are positive, these are negative, above are positive, below are negative. So for A, 2, 3, the method would be start at 0, you do your x first, which is a positive 2, go up to 3, and then you put a dot there. And you could label this, let's say, point A, or you can actually write the coordinates 2, 3. And you do that for each of these. And for B, let's do this one, -5, 0. So -5, 1, 2, 3, 4, 5, 0. This would be right on the x-axis. And then let's do letter F, 0, 5. So here you start at 0 and you go up 1, 2, 3, 4, 5. Now I plotted these points for a particular reason, because if we were to make a line through these points, something you may or may not be familiar with, we have what we call plotted the intercepts, where in this case it's 0, 5, and in this case a -5, 0. This would be your y-intercept, where it's crossing the line, or the axis. The line is crossing the axis, and here, where the line is crossing the axis. These are the intercepts of this graph. Again, reviewing and building vocabulary. Now what we're going to do is graph typical equations, but I want you to write these down as we go along. These are the main forms of equations. The first one is we're going to call number 1. This is standard form. So it'd be ax plus by equals c. Standard form of the linear equation in two variables, x and y. Equation 2, y equals mx plus b. This one is called slope-intercept form because your m value is the slope and this b value is where the equation will cross the y-axis. Therefore, it's called the y-intercept. So, slope-intercept. Now, formula 3 is the slope formula. We use the lowercase letter m for the slope. This would be your coordinates y sub 2 minus y sub 1 over x sub 2 minus x sub 1. We'll be using these a little later. These would be two-ordered pairs where we take the y values on the top, which refers to the rise, and the lower ones, which refer to the run, the x values. Put it in this form and you find the slope. And a little review, if the line looks like this, the slope is negative. If the line looks like this, the slope is positive. If it's a horizontal line, the slope is 0. And if it's a vertical line, the slope is undefined. Just as a little review. All right, a few more formulas. We'll call this one number 4. And you may recall these. Y minus y sub 1 equals m. There's your slope again. And then in parentheses, x minus x sub 1. Now here we have one ordered pair, an x and a y, and we have the slope. So this is referred to as point slope form for number 4. Number 5, a special equation for a horizontal line. And that equation is y equals b. So whatever your b value, your y-intercept, it's a horizontal line going through that value. And then number 6 is x equals a. This is the equation of a vertical line, where a is your x-intercept, and it would be a vertical line going through that x value. Again, vocabulary and review. Going on now to example 2, we'll take a look at equation A in this case, which is in standard form, and we'll want to graph it. Now there's a couple of ways to do this. I'm going to use the whiteboard to help us along. And the most common way, I think, when it's in standard form like this, is to make what is called an x and y intercept t-chart. Now that t-chart starts off looking like a T, and then you put an x and a y there, and then this part would be the T. But then you put a 0 there and a 0 there. This is going to give you here your 0, comma b, which is your y-intercept, and here a, comma 0, which will give you your x-intercept. So if a or your x here is a 0, this becomes a 0. Just divide both sides by a -5 here, and you get y is a -2. And then here, if y is 0 now, -5 times 0 is 0. You're going to divide both sides by 2, and you get x is 5. So if we plot these on our sketch here, this is where 0, -2 is, and then this one, 1, 2, 3, 4, 5, and then use the line tool that just makes your graph. So there's your x-intercept and there's your y-intercept, and we have sketched this. Now another way is you make an extended t-chart. You make more points. You get like other points 1 and put some values here, plot them in. But a very good way is to make an x and y intercept t-chart when they're in standard form. Okay, we'll clear this up and then we'll show it to you also as it looks on the graph. Here they've gotten a number of different points using that t-chart, but there's our y-intercept and our x-intercept. All right, let's take a look at the next equation. And here we'll use what's written up because there's lots of writing. But there's your equation. And it looks like they're putting it into the slope-intercept form, where they're going to solve for a positive y. So they've taken the x squared, brought that over as a negative x squared. They brought over the negative 6x as a positive 6, and that gives you your second line here. Should be taking some notes on this. Now, they're solving for y, and you solve for y by taking the square root of this side, which will give you a positive y, and the protocol is plus or minus the square root of the other side, which gives you this. So now what you do is you put in some values. This is their t-chart here. I've cut off some of them, but you get to see the values. So what do you do with those values? Well, we'll move this down a little. And you actually plot them. And lo and behold, what you have here is a circle. Now we're going to look at circles in some detail in our next lesson. Now, going on to letter C of example 2, we're looking at this equation here that I've written. And when it's in this form, this is actually a parabola where there's a 1 in front, which is our a value. -2 in the quadratic form is our b value. And in a sense, there is no c out here, which is actually a 0, which would be our y-intercept, which is different from this b that we're calling here. Let me just go over that. If we have this formula, ax squared plus bx plus c equals 0. This is standard form of the quadratic equation. Here our b doesn't refer to the y-intercept, but using it here, this is the y-intercept. It's not that same b. So that may be a tad confusing here. So anyway, you get your t-chart, get your points, plug it in, and then when you go to plot them, and let's show you that, it makes a nice graph. Now, you may or may not be familiar with the words of a parabola, let's just do a little review while we're here. This point is considered the vertex. And since it's a low point, it's called a minimum of our parabola. Now over here and here, these are the zeros. That is where your x-intercepts are found when your y value is 0. And since it goes through the origin, it's also the y-intercept. So here, these are x-intercepts. This one's also a y-intercept. And this parabola, because our a value that we had, ax squared plus bx plus c, was positive, it opens upward. If that a value was negative, the parabola would open downwards, and the vertex would be a maximum. Again, reviewing some vocabulary and preparing for future lessons. Now, the learn goes into using graphing calculators, where we get some rather sophisticated graphs where they are higher than quadratics and not a simple straight line or parabola, and they get to be some of these wavy lines here. And it tells you how to set your fields so that you are sure to get the actual points of the graph. And let's just take a note of this one here, that here it's crossing the x-axis, so that's one of the zeros. There's another, and there's another where it's just touching. It's not actually crossing. And then the changed colors will show you these are all x-intercepts in red. Here is your y-intercept where it crosses the y-axis. These are things that later in the course we'll be looking at. Another formula that you should be familiar with as we move forward is the distance and then later the midpoint formula. And let's just describe it here a little bit. So here is our line right there, this one here, going from, let me go back to red here, this point with this ordered pair, and this point with this ordered pair. And what have we done? Well, we went and did a run and then a rise. So in a sense, we formed a right triangle where this would be one of the legs, the rise, which are y values, and this would be the run, the x values. So these are the two legs. So the side opposite the right ankle that you've mentally formed here is the hypotenuse. So we're wondering, what is the length of this hypotenuse? Well, if you figure out the differences between your x coordinates and your y coordinates, square them, and then that would be equal to the square of the diagonal, which is the hypotenuse. But then if you took the square root of this, which is what they've done here, this gives you what is called the distance formula. So it's just a matter then of an example that they're going to give you shortly to substitute for these x and y values, carefully following this formula. It'll give you the length of this hypotenuse, that diagonal. So you want to include this in your notes, and there they're actually showing you d squared is the difference of these, and eventually the distance formula. Again, pause as needed. We said we'd give you an example, and here is example 3, letter A. So there are 2 points in ordered pair, x sub 1, y sub 1, and then x sub 2, y sub 2, and we're just going to put them carefully into the formula. And I'll pause here a little bit. You're going to pause and write these down. So here, this is the opposite of a negative here, makes this a positive. So -4 and a +7 gives you a +3 that you're going to square. And this is a -2 and a -2, which adds up to a -4 that you're going to square. So this gives you a +16. When you add these two together, you get a +25. The square root of 25 is 5. So we know then wherever that diagonal is, one side was 3, one side was 4, and the diagonal is 5. And we figured it out using 2 ordered pairs, using the distance formula. All right, let's take a look at the next one. I'll raise it up right here. And notice now, after putting in these other values, we don't get a perfect square, but we are asked to simplify the radical 40, and the protocol for that is there a factor of 40 that is a perfect square? Yeah, 4 times 10. And what is the square root of 4? 2. So the exact answer of this is 2. The square root of 10 would be the length of that diagonal. But if they wanted it rounded to a number of positions, here they're showing you what it would be approximately in decimal form to, let's see here, 2, 4, 6, maybe 8 decimals. Wow. Again, you'll be doing your practice and certify to hone your skill of working with the distance formula. Now, looking at the midpoint formula, on this next slide, they're introducing a nice graph where what would be the middle of that hypotenuse there, that diagonal? Well, you can kind of say it's about there. Well, what would the measure of it be? Well, if you took your two x values and then divided it by 2, and your two y values here and divided it by 2, that would give you the ordered pair of that midpoint. And that's what they're doing. And I should have cleared that up. Let's pause and reflect on it again. So what is the midpoint formula? Again, sort of an easy one. Adding the two x values, dividing it by 2. Adding the two y values, dividing it by 2. The midpoint formula. Take a moment, write it down. All right, here is example 4. And there are 2. Then you'll write these up, and I'll go over them with you. So there's your 2 ordered pairs. You're going to take the two x values, the 5 and a -1, add them up. Here we end up with a 4 over 2, which is 2. Then a 1 and a 3 add up to 4 over 2. And we get the ordered pair 2, 2. That one's sort of straightforward. Now, for letter B, our x is 3 and -6, which is going to end up as a -3 over 2. And then a 0 and an 11 divided by 2 gives you 11 halves. Okay. And this will complete topic 1 of chapter 2.